This is my time frame, inspired by the Kickstarter project Slow Dance. So, what is it? It's a frame that makes things look like they're moving in slow motion. So, how does it work? An object is attached to a sprung piece of metal, which is moved back and forth by an electromagnet in a cyclic motion. The object is lit by a strobe light, which causes a stroboscopic effect, so it appears to be moving in slow motion. For the strobe light, I used white LED strip lights. They go all the way around the inside of the frame and into the base. On the bottom of the frame are the controls, which are two potentiometers, and there's a hole for the power lead. The feet are removable and held on by neodymium magnets, which are attracted to the screws. Here you can see the components inside the frame. First, there's the electromagnet I wound in a 3D printed mount, which also holds the sprung strip of metal. You can see I've added two neodymium magnets to the strip of metal, which increases the amplitude of the movement. The circuit uses an ATtiny 85 microcontroller to control the strobe and electromagnet's frequency and duty cycle. The LEDs run at 12 volts and are switched on and off using a transistor controlled by the ATtiny. The electromagnet runs at 5 volts to prevent it from overheating, and is controlled by an H-bridge because it requires the voltage to be applied in opposite directions to change the polarity of the magnet. You may have noticed my improvised heatsink made from an aluminium ruler, which helps cool the voltage regulator. The two potentiometers control the frequency of the strobe and electromagnet independently. This allows the magnet's frequency to be tuned to the object's resonance frequency to yield the largest movement. Then the strobe frequency can be set to give the desired speed and effect of the object's movement. The minimum strobe frequency was set to approximately 70 Hz. This is because if it's lower than that, then you may start to notice a flickering effect. The duty cycle of the strobe was set to 12.5% or an eighth, because otherwise the object would travel too far in the time the light was on and appear blurry. Here I'm adjusting the strobe frequency so you can see the effect it has on the feathers. When the strobe frequency is set near to double the electromagnet's frequency, it will appear as if there are two feathers passing through each other. When the strobe frequency is exactly double the magnet's frequency, it will appear as if the feather is stationary, but there were two images of it.